Okay, so in this video, we'll be continuing on with our series of doubly linked lists, and we're going to be looking at how we can delete a node in a doubly linked list. And what we're going to be doing is we're going to be going over the specific cases in which we'll need to be careful for when we think about how to solve this problem. So we'll be visualizing those cases on these slides, and then we'll be going through how to actually implement these cases in Python. And then when we do the implementation, we'll periodically go back and forth between the code and the slides just to make sure that the cases that we have accounted for are being properly accounted for in the code. So basically, let's just go through each of these cases for deleting a node one by one. So one scenario in which we have a doubly linked list and we want to delete is a scenario where we have something that looks like this. We have a doubly linked list which only consists of one node. So it's just the head node, and that therefore the head node only has a next pointer to null and it has a previous pointer to null as well. And there's only one node in that list, and that node is the head. So in this case, if we say that we want to delete the node, let's say with key A, so we're given this linked list, we find the node with key A is this node right here and the list is of this form, then what we want to end up with at the end of the day is a list looks like this, essentially an empty list. So we want to get rid of that node. So that will entail basically removing the head, essentially setting the current node that we find to be equal to the one that we want to remove, setting it equal to none, and making sure also that the head of the list is also set equal to none. So that will give us what is represented here as an empty list. So let's take another case here. Let's assume again that the node that we do want to remove is also still the head, but now there's more than one other node in the list. Namely, there's this other B node. So it can be any other number of nodes, but if there's at least one node which is the head and any other number of nodes here, and the node that we want to remove is the head node, this is the other case that we can think about. So in this case, it's a little bit different because now we have next and previous pointers, whereas before those didn't exist in this case. We just had a next pointer and that pointed to null. So now we have this case too where we want to remove this node right here, and in that case we also need to make sure that we update the head of the list to be appropriately moved over to this node over here, because this will now be the new head of the list once this is removed. So in order to properly remove this node, what we need to do is we need to make sure that the next pointer of this is set to none, because no longer is this node going to be there. Also, the previous pointer of this node over here shouldn't point to this node over here because we're going to remove this. It should instead point to the previous node, which is none. So that's because it will now be where A is, so it'll be right there. And one other thing that we need to do as well is we need to make sure that we update the state of this node to be the head of the list, because again, we've removed what was previously the head of the list. We've updated that to be the node that was right after, essentially the node.next of that. So that is now B. So there's two more cases to consider. Consider this case here. So again, we have a doubly linked list, and assume that we want to remove a node in the list that doesn't have that has a next pointer that is not none. So for instance, in this case here, the next pointer of D dot next of that is none. So this would not qualify under case 3. However, if we wanted to remove, let's say, node B, this does qualify because the current next, let's say this one dot next is equal to this guy. So the next pointer is not pointing to none, it's actually pointing to a node. So this is covered by case 3. So in this case, what we want to do is we want to make sure that B goes away, because that's, in this example, the node that we wish to delete. And we want to make sure that the next pointer of this one here points to C, and likewise the previous pointer of C points to A, and then we just totally get rid of B altogether. So we should have something that looks like this. So the other last case that we'll consider is sort of a play on case 3, or it's a variation of case 3. That is where current.next is actually none. So again, consider this linked list here, this doubly linked list that we have, and assume that the node that we want to remove has a next pointer that points to none. So the only case where that's going to happen is when we have the node that we wish to remove is actually the last valid node in the doubly linked list. So in this case, it's this D node here. So in this case, what we want to do is similar, but what we want to make sure that we do is we want to get rid of this, so remove this node, and then also update the next pointer of the previous node, in this case C, to point to null. because now C will be the last node in this list. And we also want to make sure that the previous pointer of D no longer points to C, because again, we're getting rid of this node. So this previous pointer should point to none, should not exist, and D should also not exist. So we should see something that looks like this, where D was previously the last node in the list and it pointed to none, and now we have C is the next node, and therefore that is actually now the last node in this list. So those are the 4 cases. We will be going back and forth between the slides to make sure that we cover those cases in the code. Let's just go back up to case 1. I'll minimize this and go to the code, and then we'll actually go and code it up. So right now what I have here is I have a function which is called delete, and that is the prototype for the function that we'll be filling in this video. So it takes 2 parameters, self, since it's a member of the doubly linked list class, and it also takes in a key. So key is the node. It's essentially the data element of the node we wish to delete. So we're going to go through that list and look for that node that has that key and then try to delete that node. So let's go ahead and do that. So I've also created a doubly linked list object here based on the class and appended elements 1, 2, 3, 4. So we'll be playing around with the delete function once we actually fill it in. So let's go ahead and take care of those cases one by one. So the first thing that we're going to do is we're going to set a pointer equal to the head of the list. We'll call that pointer current, and that pointer is going to progressively move throughout the list, and all the while we're going to be considering whether or not the data elements of the nodes that we encounter essentially correspond to any of the 4 cases that we considered in the slides. So while current is not null, so while current's a valid pointer that is not pointing to null, we're going to keep moving on in the list. So let's go ahead and take care of case 1. So let's remind ourselves what case 1 is all about. So again, case 1 is when we have the node that we wish to delete is actually the head node, and there's no other nodes in the list. That is, the .next pointer points to none. So if these things occur, then we're going to take care of that as case 1. So we'll actually put in a comment, we'll say case 1, and then we'll have an if condition that says if current.data is equal to the key that we want to delete and current is equal to the head of the list, then we're going to take care of it as we did on the slides. So basically we're going to check. We're going to make a check and say if not current.next. So what is this checking for? This is checking, let's go back to the slides. This is checking if the next pointer of this guy is pointing to a node or if it's pointing to null. In this case, this next pointer is pointing to null. It's not pointing to anything at all. It's not pointing to a node. Where in this case, the next pointer of the head node is actually pointing to a valid node. So if this is not pointing to any node, let's go back to the code. If not current.next, that's the case that case 1 corresponds to. It's not pointing to anything. It's only one node in the list. In that case, what we want to do is we want to set current is equal to none. So that just kills off that node. And then we're going to also set the head of the list equal to none. Because remember, the head of the list was initially A, the node that we had here, A. But we're getting rid of that node. So we're getting something that looks like this. So we are going back to an empty doubly linked list. So just to go back to the code, we've set the head equal to none, and then what we're going to do is just return since we've done what we've came to do, and that's all we need to do in that case. Okay, so that's case 1. And I'm actually going to put case 1, the comment, down here because technically this if condition here is case 1. So let's go ahead and do case 2. So what is case 2? Case 2 is similar. We have this scenario now where we want to delete the head node, but we have the .next pointer pointing to something that is not null. That is, we have something else here that is a node, and we need to treat that differently than if this was just pointing to none. Okay, so that is case 2. So let's go to the code and think about what we need to do. So else, if current.next is pointing to a valid node, let's go ahead and create a pointer that points to current.next. Let's create the pointers, let's call it nxt, and let's say that's equal to current.next. So we're going to store this thing so we can actually manipulate these arrows, these pointers, in such a way to remove this node here, because we want to keep track of what this node is. We want to keep track of where the head is. We want to move things around in such a way to get to this orientation here. So let's go ahead and think about how to do that. So what we want to do now is we want to say current.next is equal to none and current.prev is equal to none. So why am I doing this? So let's go ahead and go back to the slides. So what I'm doing here is our current node is this one right here, right? So we want to get rid of this arrow. We don't want it to point to B anymore. We don't want this previous pointer to point to null anymore. well, I mean, we don't really care. It already points to none, so it's kind of a bit of a redundant statement to say that. But we certainly don't want this thing to point to B. We want it to point to none. So that is what this line is achieving here. This current.next is equal to none. We can actually get rid of this statement because that doesn't really matter. So the next thing we want to do is we actually want to get rid of that node with the data element A. We want to say current is equal to none. And then what we want to do, so we've gotten rid of the node. We've gotten rid of this node here. The dot next pointer doesn't point to anything. We do want to update the dot previous pointer of this thing here. So we do want to say this dot previous shouldn't point to A anymore, but it should point to null. So perhaps that's what I meant to write up here. So current.next is equal to none. We'll keep that. And then we'll say next.prev is equal to none. I think this is what I meant to actually write initially. So the dot next pointer doesn't point to B anymore. It's gone. The dot previous pointer of this guy right here, which again we stored in the NXT pointer, which points to this thing right here, we don't want it to point to this one here because we're removing it. We want it to point to null. So that's what this line here achieves. We're saying point the previous pointer of the node that stores B in that example to null, and then we're killing off that node that stores A. So we need to do one final thing, and that is update the status of the head pointer. So self.head is equal to nxt. So again, we move the status of the head pointer from A to B. So B now is the head of the list because we've removed A from the list, and B is the first node, so therefore it's the head. And then, like we did before for case 1, we'll return here because that's all we came to do. Let me just let's see, let me just move this. This is actually, this should be indented inside of that if statement. So this is case 1, this is case 2, and we'll move right along. So that takes care of the case when we want to remove the head node, and either there is a node following the head node or there isn't. So those are case 1 and case 2. Now we want to take care of the other two cases where we don't want to remove the head node. We want to remove either node in the middle or either the last node. So those are two separate cases. So let's have an else if here, else if current.data is equal to the key. So otherwise, so this if statement checks if it's equal to the key and it's equal to the head. Otherwise, we'll just move right along in that list and we'll check if the data element of the nodes that we encounter further equal the key that we want to delete. So that's what this else if condition is. So now let's go ahead and go back to the slides and take care of case 3. So let's just remind ourselves what case 3 is. So basically case 3 is the scenario where we want to remove a node in this doubly linked list and current.next is not none. So that would be, an example would be if we want to remove this node with B, with C. It would not be an example if we wanted to remove D because .next of D is none. So let's assume that we want to remove B in this case. So if we want to remove that, we should get this list here where B is gone. So let's think about what we need to do in order to remove B from the list. So again, this really comes down to reorienting these pointers in such a way that the .next of the previous pointer to the current one points to the next one of the current one, and similarly for the previous pointers. So we just kind of want to make sure that we stretch these arrows around B and then kill B off because we're deleting it. Let's go back to the code. So what we're going to do here, we're going to say if current.next, so this is the case 3, if current.next has a node after it, this is the case that we care about. We're going to again, let's create a variable called nxt, which is a pointer to current.next, and then let's also create a pointer to the previous node of the current one. So we'll say prev is equal to current.prev. So what do these pointers do? So in the case that we want to remove B from the list, we now have nxt, which is a pointer to the next node in the list, respective to B. And then we also have a pointer to the previous node of B, which is this one right here. So we want to remove this node, and we have the information that corresponds to this node right here, which is the next one, and this one right here. We want that information because we want to reorient these pointers in such a way that moves around B. Let's go ahead and do that. So the first thing that we can do is we can say prev.next is equal to nxt. So what is this doing? We're saying prev.next is equal to nxt. What is prev.next? So this is the current node. Prev.next is equal to this one, and we're saying that prev.next is equal to nxt. nxt is this guy over here. So we're stretching this next pointer over to C. So that's what we're doing there. Next thing that we want to do is we want to say nxt.prev is equal to prev. So what is this doing? So again, nxt is equal to current.next, right? So then we're saying the previous pointer of this guy right here should point to this thing, which is A. So again, we're stretching the previous arrow from C to A. So we're kind of bypassing B. So we did the bypass from A to C for next, and now we're doing the bypass from C to A for the previous pointer. And then what we want to do is we want to just kill off the pointers that aren't doing anything. So for instance, current.next is equal to none, and current.prev is equal to none as well. So what is this doing? This is making sure that we don't have this .next pointer from B to C, and we don't have this .previous pointer from B to A. So we're getting rid of those because those, we don't care about those anymore because we're removing B. Let's go ahead and also say current is equal to none. That will get rid of the node that contains B in that case. And then just like we did for the other cases, we'll return. So let me go ahead and put a comment here that says case 3 right above there. And then let's move on to case 4. So case 4. And again, case 4 was almost identical to case 3, only instead of current.next is not none, case 4 is when we have current.next is none. So that specifically corresponds to the case when we're removing the last node, because this one doesn't have, it only has a .next, it doesn't have a .previous as well, because there's no other node over here, it's pointing to none. So we need to take care of this case specifically. So let's go ahead and say, in case 4, let's give an else here. So if current.next is actually none, then let's go ahead and we'll follow a pretty similar type of idea to what we did up here for case 3. We can't do this because there's no .next for the pointer that we're on, because again we're removing the last element. But we do want to store the information of the .previous pointer, because again we're kind of stretching this arrow, this next arrow, to point to null. We're removing this node here, that's going away. The .next pointer should stretch over and point to null. So let's go ahead and store a pointer to the previous node of D in that case. And let's say that's equal to current.prev. And then let's say prev.next is equal to none, current.prev is equal to none, and current is equal to none. And then we'll return. So let's break down what's happening here. So what we're doing in this case, so again, we had this pointer that stores to the previous node, that is the node that contains C, and we're saying, okay, take the next pointer of this thing, take the next pointer of C and point it to null. So previous.next is equal to null. So that's what we're doing. We're kind of stretching that one around. And then we're also saying current.previous is equal to none. There's no previous, so this node here, the .previous is C. We're removing this node. We don't want a previous, so we're getting rid of that. We're setting that to none. And then we're also current is equal to none. Current is the node with D in this case. We're getting rid of that node, and then we end up with a list, a doubly linked list that looks like this. So again, that should do the trick there. And then we want to make sure that this is all in a big loop, right? We're moving the current pointer from the head of the list all the way through the list. So we want to make sure at the end here what we do as we iterate through the loop is we want to say current is equal to current.next, as that will move the current pointer from the head all the way through the rest of the list. Okay, so let's see. Let's go ahead and try to see if we can actually delete elements using the function that we have. And I notice that this is this is indented not far enough, so I'm going to go ahead and give that one indent because I want that to be inside of the while loop. Okay, so let's go ahead and try to run the delete command on the doubly linked list that we have. So again, we have a doubly linked list object. We've appended the elements 1, 2, 3, 4. Let's go ahead and try to see if the delete command works as expected. So we'll say doubly linked list dot delete, and then let's go ahead and try to delete the head node, so the one that corresponds to having 1 in this case. So we'll write that, we'll give it a run. I'm actually going to clear the screen first because I think there's some content on the screen. It'll be a little bit easier if I clear it first. Let's see, let's try that again. Clear. Right, so let's try and run that one more time. Right, so we've removed the 1 from the list, the doubly linked list, and we have elements 2, 3, and 4. Okay, so that seems right. Let's go ahead and try to delete an element that is not present in the list. So let's go ahead and try to delete 6. So 6 is not present in this particular list. Let's go ahead and see what happens when we try to delete it. So we'll go ahead and do that. So again, we see the list 2, 3, 4. So it realized that 6 is in the list. The pointer starts at head, moves through the list, doesn't encounter 6, and just returns the list that we had after we performed the first delete here with 1. So let's try to delete 4. Let's try to doubly linked list dot delete node with 4. Let's go ahead and try that. So again, we have 2, 3, 4, but then we have 2, 3 since we got rid of the 4. Let's go ahead and delete the other elements as well. Let's say doubly linked list dot delete 3, and then also doubly linked list dot delete 2. Let's see what happens there. We should get an empty list. So indeed, there's no output. We have an empty list. Let's just get rid of one of those deletes. Let's make sure that we have one element if we just delete the 3 instead of 3 and 2. So we have 2. That's what we expect. So that pretty much does it for this video. If you have any questions or comments, please don't hesitate to leave them in the comment section below. As always, the code for all these videos will be provided on my GitHub page as always. Thanks again for taking the time to watch, and have a great day. Bye-bye.